Welcome to Math Mondays. I'm Miss Barnes, and this segment is for kindergarten through second grade learners. Good morning, friends. How are you doing today? Today we're going to be working on adding and subtracting within 20. Our objective for the day is I can solve real-world problems using a model. Last week you may remember that we worked on adding to 10. That means the sum of our problems does not exceed or go over the number 10. Today we'll be working with sums and differences up to 20. And we will be using models today, so you will need a piece of paper and something to write with. Take a second now, and let's get ready to learn. All right, let's get started. Here is your very first problem for the day. We're going to talk about the steps to solving this problem, and we are going to use a specific strategy. The strategy looks a lot like a bar model, so make sure that you have that piece of paper and that writing utensil so that you can follow along with me. The first step to solving the problem is that we have to read the whole problem from beginning to end. We're trying to understand what's going on in the problem. So let's read it together. Emma planted 8 tulips last week. Today, she planted some lilies. Now she has 17 flowers. How many lilies did she plant? So our next step is to turn the question into a statement. Can you find the question on your screen? What are you being asked to calculate? All right, that's right. You're being asked how many lilies did she plant? So the next step is to take that question and make it a statement. How do we do that? What kind of punctuation do we need on the end in order to make it a statement? That's right. We need a period. So at the bottom of your screen, I'm going to turn the question into a statement. I'd like you to do the same, and then let's check our answers when we're finished. All right, my statement says Emma planted blank lilies. What does yours say? If it doesn't match mine, just make sure it sounds similar. You could have written blank lilies were planted. You could have written there are blank lilies. Just make sure that your statement will answer the question at the very end. What's the next step? Well, the next step is now we have to think about our problem and we have to create our model. So we're going to walk through each and every step very slowly so that you can try it later on. So the first step in creating our model is to think about the subject of our word problem. Looking at the problem, can you pick out some key words that you see? I see tulips, lilies, and flowers. What do you think would be a great word that we could use to summarize our problem? What is this problem about? Our problem today is about flowers. And then we're going to draw a vertical line. The next step is to go back to your problem and read it sentence by sentence, stopping at each punctuation mark. And then we'll model it using our bar model below. So let's do that. Let's read the first sentence. Emma planted 8 tulips last week. And there's a period, so we're going to stop there. How do we model 8 tulips? So we're going to draw the piece of the model here. And inside the model, inside the bar, I'm going to write how many tulips Emma planted. And we know that she planted 8 tulips. Above the bar, I'm going to label this so I don't forget. She planted 8 tulips. Let's read the next sentence. Today, she planted some lilies. And there's a period, so we're going to stop there. Well, how do we model that? We don't know how many lilies she planted yet. So we're going to draw a second piece to the bar. And inside the bar, we are going to put a question mark. Why would we put a question mark there? That's right, because we don't know how many lilies she planted. And then above that part of the bar, make sure you label it with lilies. Are you ready to read the next sentence? Now she has 17 flowers. And there's another period, so we'll stop there. What is the number 17? What does it represent in our problem? Is it a part? Is it the sum? That's right, it's the sum. So when you have the sum, we're going to write the sum to the right of the model. Okay? So this is what your completed model should look like. We have the subject on the left, the bar model with 8 tulips and some lilies, and the total of flowers on the right. Great job. That was a long step. The next step is to write a number sentence using your model. So can you write a number sentence using the model here? Remember, a number sentence has an equal sign. So I'm going to take 8 tulips, and I know that I need some lilies, so we're going to add some lilies in order to get 17 flowers. Okay. So now we have to find the missing part. We have to solve the equation. Can you think of the missing number? If you've already guessed it, go ahead and just hang out for a second. We're going to talk about how to solve for this missing number. So 17 is kind of a strange number to add to, and 8 isn't a very friendly place to start. Can you think of a way to make a more friendly number first? I would make a 10. So what number adds to 8 to get 10? Well, I know if I count on 8, 9, 10, 2. So part of this answer has to be 2. Well, 8 plus 2 is 10. How do I get from 10 to 17? That's right, I add 7 more. So the missing part of this is 7. What's 2 plus 7? That's right, 2 plus 7 equals 9. And you have just solved our math equation. Great job. So when you're finished solving your number sentence, whether it's subtraction or addition, you need to write your answer statement. We already completed part of this down below. And our statement right now says Emma planted blank lilies. Can you fill in the blank for me? How many lilies did Emma plant today? Great job, Emma planted 9 lilies. So here in the space in our problem, I'm going to write the number 9. Now there's one very important last step, and that very important last step is to go back and reread the whole problem and your answer statement to make sure everything makes sense. This is really important because if you go back and reread and you think, what? You need to check your answer. Okay? So let's do that here. I'm going to erase all of the stuff at the top. And we're going to reread the problem and our answer statement at the very bottom of the screen. Ready? Emma planted 8 tulips last week. Today, she planted some lilies. Now she has 17 flowers. How many lilies did she plant? And our answer statement says, Emma planted 9 lilies. Does that make sense? Great job on that problem. Here's the problem that I'd like you to work by yourself this week. Kaya has 8 blue socks. She has 4 red socks. How many socks does Kaya have in her drawer? We spent a lot of time going through that model this morning. So if you get stuck or you can't figure it out, make sure you go back and see if you can draw similarities between the problem that we did together and the problem that I'm asking you to do this week. Remember, if you'd like to share your work with me, you can find me on Twitter at MissB_KCPS. That concludes our lesson today. How are you feeling about our objective? Let's review. I can solve real-world problems using a model. So remember today we went through 2 problems together, and you learned how to read the problem and dissect, take out the important information. We also learned how to use a bar model in order to show what we're reading and understanding from the word problem that's in front of us. How did you feel you did today? I bet you did great. Make sure this week you take some extra time to practice some word problems. I encourage you to write your own even, and maybe see if someone in your family can solve it for you. And maybe you can even teach them how to model a word problem using the strategy that we did today. It was my pleasure having you in class today. I'll see you next week.
Good afternoon, friends. This is Ms. Shields from Faxon Elementary, and today we are here to go through and solve some problems using area and perimeter. We're going to go ahead and get started. I have for you here on the screen a geoboard. A geoboard is a board that uses rubber bands, and we can use those rubber bands to help identify what the perimeter is and the area by sectioning it off. So we're going to go ahead and think about what is perimeter. Perimeter is everything around the outside of a rectangle. We think about it as taking steps along the outside of a fence. So if I had a fence, this is my backyard, and I put a fence all the way around my backyard, I would have to take my steps to determine how much my perimeter is. The area is all the grass inside of your fence. It is on the ground. Think about area like an area rug in your living room, and it covers a space on your ground. It covers an area. So I'm going to use these rubber bands here today to help us create a rectangle that we are going to use to identify our area and our perimeter. So I'm just going to go ahead and set this up here. And you'll notice that I am going to use 2 different colors. And there is a reason why I want 2 different colors. All right. So I have here for us our first rectangle that we're going to work with. And I want us to talk about the perimeter first. When we talk about perimeter, we can, like I said before, count around the outside, or we can create a formula. Now, I kind of like using formulas because I feel like there's no way I can get an answer wrong if I fill in what is missing correctly. So in this case, I have a perimeter equals 2L plus 2W. We're going to have to replace that L and the W because otherwise we don't know what goes there. So that L stands for length. And so we're going to think about how long is our rectangle. So we're going to start by counting just so we can get in the hang of it. So counting our length, let's count it. We have 1, 2, 3, 4, 5. So it is 5 squares long. That's what that means. So we're going to replace that L with a 5. So, and now we're going to replace the W. W stands for width. How wide is our rectangle? So again, we're going to count 1, 2, 3, 4, 5. It is also 5 squares wide. So this rectangle is 5 squares long and 5 squares wide. It is also called a square, but a rectangle is a square. So now we are ready to go ahead and solve that problem. What is 2 times 5? Very good. 2 times 5 is 10. So we have 10 plus 2 times 5 again. What is 2 times 5? Yes, 10. So now we have 10 plus 10. And 10 plus 10 equals 20. So our rectangle is 20 squares. So if we were counting, going around the outside, we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we, using our formula, got the correct answer. So now let's try a formula for area. Area is the length times the width. The length times the width. And we have already found how long and how wide our rectangle is. So let's look at it again. It is 5 squares long. And it is 5 squares wide right here. So now our problem becomes 5 times 5. What is 5 times 5? Very good, it's 25. 5 times 5 is 25. So we did not come up with the same answer, and they're not always going to be the same answer. So let's look on the inside. We have 1 square here, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 squares are on the inside of our rectangle. I'm going to create another rectangle for you. And I want you to, after I create this rectangle, I would like for you to pause the video and work through the area and the perimeter. I want you to tell me, after you work through it, what is the area and the perimeter? And then you're going to come back and we are going to make sure you have got the correct answer. So here is the new rectangle that I have created for you. I would like for you to go ahead and pause the video right now and solve area and perimeter. See you soon. Good luck. Hey, welcome back. All right. I hope you guys were able to solve that problem. We are going to spend some time and just double check your work and make sure that you have the correct answers on how to find the area and perimeter. Let's go ahead and get started with that formula for perimeter. Remember, it is 2L plus, and 2L stands for 2 times L plus 2 times W. 2 times the width plus 2 times the length plus 2 times the width. All right, let's go ahead and think about this. So we are going to replace the stuff that we did not know. We had to go ahead and solve for the length. How long is our rectangle? Let's go ahead and check. 1, 2, 3. So this is going to be 2 times 3. Plus 2 times W. Let's go ahead and solve for W. Let's see how wide it is. 1, 2, 3, 4, 5, 6, 7. So 2 times 7. All right. You are ready to go ahead and solve that math problem there. What is 2 times 3? Very good. 2 times 3 is 6. And then what is 2 times 7? Excellent. 2 times 7 is 14. So we have 6 plus 14. 6 plus 14. You came up with 20. Very good. Now you notice here that this rectangle was also a perimeter of 20, and so is this one. But do they look the same? No, they have 2 completely different shapes, and that is okay. All right, we are going to go ahead and solve for area. Area, remember our formula is length times width. And our length, we said, was 3. So our length was 3 times our width, which we determined was 7. 3 times 7. 3 times 7, boys and girls. Excellent. 21. So this rectangle has a perimeter of 20 and an area of 21. That is all I have for you today. I hope you guys can use these strategies when you are working through and solving some problems with area and perimeter. Please remember, you can always reach out to your teachers or myself, and I would be more than happy to help you solve these problems. I'll see you soon. Have a good day.
Kindergarten is great at Kansas City Public Schools.
I know they have really good teachers. I know this is great school.
They teach them stuff that I thought my kids would never be able to know at the age of 5.
Since deciding to send our kiddos to a neighborhood school, we've become even more of a part of our community.
Now is the time to enroll your future kindergartner for the new school year. Visit enrollkc.org today.
Hello, my name is Jo Fender, and this is Math for Middle School. Today we're going to be talking about powers and how they function when we use them in expressions to evaluate that expression. You'll need paper and pencil and possibly a calculator if you have it handy. So take a few moments and let's get ready to learn. So last week we talked about how parentheses affect a power. Now our first example is -5 to the second power, and you'll notice that -5 is in a set of parentheses. And that's going to tell us that our base, -5, is going to be our factor that we are repeating. Now remember our exponent? That tells us how many times that factor is going to be repeated in our multiplication. So for this particular example, we're going to say -5 times -5. Now remember, a negative and a negative, when you're multiplying or dividing, create a positive. So 5 times 5 is 25. So our answer, or our product for this particular power, is going to be 25. Now you'll notice our second example, the -5 to the second power, is not using any parentheses. And that tells us that our base is only going to be the 5, not the -5. And when we think about that, I sometimes put a negative and then our parentheses, and then our repeated multiplication inside that parentheses to tell me that, hey, you know, I'm multiplying those two 5s together, but whatever my product is, I'm going to create its opposite, or its negative. So in this particular case, 5 times 5 is 25. I'm going to bring that opposite down, and my product is going to be -25. So last week, I hope you remember, parentheses makes a difference when we're talking about powers and applying that factor, or that base, with our exponent. So let's look at that same concept, but this time with fractions. And fractions has a tendency to get a little bit messy or complicated. And when you're in 8th grade and when you're in 9th grade in Algebra 1, this is going to play a really big factor in your power work. So again, your base in -3/4 to the power of 3, your base is that -3/4. Remember, our power, or our exponent, is 3 for our power. So we're going to say -3/4 times -3/4 times -3/4. When you're multiplying fractions, you need to remember all of those fraction rules, and we're going to work in groups of 2. So when we're doing that, we're going to multiply our numerators and our denominators together. Remember, integer rules still apply with negative and negative make a positive. So I'm going to multiply my 3's, that's 9. I'm going to multiply my 4's, that's 16. Now I'm going to bring that extra -3/4 down, multiply it to what I got with the first 2, do the same thing, multiply across, numerator, denominator. But this time you'll notice a positive and a negative. When you have unlike terms and you're multiplying or dividing, that creates a negative. So we're going to say 9 times 3 is 27, and 16 times 4, is 64. Make sure you're looking for simplification here. If there's anything to simplify, please do that. I don't think there is, so my answer is going to be negative 27/64. Now let's take a look with my fraction that does not have parentheses. It's a negative, it's to a power of 3, but this time my power is only on my 3 to the 3rd power, in the numerator only. So the way that's going to look like is I'm going to go ahead and put my negative so I don't lose it. And I'm going to put that in parentheses, and I'm going to say 3 times 3 times 3, because my power is only on my numerator, remember, and my denominator is going to remain 4. I'm going to close my parentheses so I know what I need to work with. I'm going to multiply 3 times 3, that's 9, times my extra 3, that's 27. My denominator is not being multiplied times anything, so I'm just going to bring it down. It's still going to remain 4. Remember, I had that negative. That negative means opposite of whatever I get for my product. So this particular answer is going to be negative 27/4. It's okay in middle school to leave an improper fraction. I actually would prefer you to leave that, because when we're working with expressions, normally we're going to have to do something else to that number or that term, and we're just going to have to switch it back to an improper fraction if we change it to a mixed number beforehand. So just remember, keep it as an improper fraction. It's the equivalent of a mixed number. It just looks a little funny, but it's still going to be good to go, okay? Let's continue. So let's evaluate. What does the power look like in an expression? Well, we're going to have to remember order of operations. And order of operations, you probably start learning somewhere around 4th, 5th grade. And you're going to learn that you're going to use your grouping symbols first. Now, you're going to start out with just parentheses. But as you progress in school, starting around the 8th grade, probably in the 7th towards the end of the year, you're going to be throwing in brackets, maybe braces, and maybe even, most likely, fractions. And remember, fractions are just another way to say division. So make sure you're looking for your grouping symbols. We're then going to work with exponents. And then remember multiplication and you need to do division at that same time. Now, what I find most students forget is multiplication and division are opposites, so you need to do them in the same step. But whichever comes first, working left to right. We read left to right, so we need to do our math left to right. And then we have addition and subtraction. Now, addition and subtraction are the same thing as multiplication and division. We need to do them in the same step, working left to right. Okay, so let's look at our first example. We have 18 divided by 2 plus 4 to the 2nd power. We don't have any grouping symbols, but we do have exponents. So we're going to have to solve our exponents first. So remember, our 4 is our base. We have a power of 2, so that means that we're going to be multiplying that 4 twice. We know 4 times 4 is 16. Now, when you get up to the higher grades, your teacher is going to want you to show your work. And it's going to be very important, especially in high school, college, and even in careers that are engineering and mathematically based. You show your math because somebody's going to have to look at it and proof it, looking for mistakes or errors. And if you don't show your work, you're not communicating your thought process. Normally, you're not going to be sitting next to that person when they're going over your math, so they just can't say, hey, what did you mean by this? So you need to show your steps. So 4 to the second power is 16. Bring down your 18 divided by 2. So we have division and addition now. So when we look at order of operations, multiplication and division is next. We just have division. So we're going to do that portion. So 18 divided by 2, 9. We're going to bring down our addition. That's the last part of order of operations. So 19 plus 16 is 25. 25 is your answer. Please make sure that when you're showing your work, you circle your answer so your answer kind of stands out and becomes obvious to whomever is looking at it. Let's try another one. So this time we have a pair of grouping symbols, and we have parentheses, 5 squared plus 2. You're going to close your parenthesis times 3. So remember, grouping symbols are first. We do have a set. They're right here. And within those grouping symbols, we need to go back and think, okay, we need to do order of operations within those grouping symbols. Sometimes you'll have another grouping symbol. In this case, we don't. We just have a power and addition. You're right, powers do come next. So when we look at that power, 5 to the second power, 5 times 5, 25. So we're going to put that 25 plus 2 back in parentheses because we're not quite done with that. And we're going to multiply times 3. We're still not done with our parentheses, so we need to figure out what 25 plus 2 is, 27. And then we're going to multiply that times 3. So 27 times 3, hope you got 81. So our answer is 81, and that is our final evaluation for our expression. We have time for one more. This time we have multiple things inside our parentheses. So notice we have our grouping symbol here. This time we have addition, multiplication, and a set of, or a group of powers. Remember, exponents, multiplication, division at the same time, addition, subtraction. So we're going to solve our powers first. So 3 times 3, thank you, 9. I'm going to copy everything down so I don't lose anything. I'm going to finish working in my grouping symbol. 9 times 5 is next. That's 45. I'm still not done with my grouping symbol. Very good. 2 plus 45 is 47. I'm going to bring down my minus 2 to the power of 3. Now I'm ready for that exponent that's off to the side. So remember, 2 times 2 times 2, that's 4 times 2, that's 8. So now I have 47 minus 8. Very good, 39. So that is my final evaluation for that expression. Please remember order of operations when you're working with these, and remember the base and the function of the base and the function of the exponent. That's all we have for today. Thank you for joining me. Remember, our goal today was to use powers and evaluate expressions using those powers. I hope to see you next time. Please remember, keep practicing math. You'll get better with time. I hope to see you next week. My name is Jo Fender.
Thanks to the investment approved by our board of directors, we have engaged our external environmental engineering firm to perform air and water quality testing in all of our buildings. Based on the data gathered from that testing and federal CDC recommendations, we are increasing the amount of fresh air coming into our buildings and installing higher grade filters for our heating and cooling systems that trap and capture 98% of airborne particles. In addition to our intensive and specialized cleaning efforts, we are improving indoor air and water quality and COVID-19 filtration in our schools. We will rotate those filters at a faster rate than recommended, just to be safe. We will also install continuous room air disinfection systems with HEPA filtration and UV sterilization for larger spaces that accommodate bigger crowds, such as gymnasiums and cafeterias. These systems will clean the air in those spaces 6 times per hour and use UV lighting in the chamber to kill pathogens.
Hi, my name is Lizelle Ofield, Custodial Service Director for the Kansas City Public Schools. Our custodial team is dedicated and committed to providing a safe and clean environment for our students, teachers, staff, and visitors. Over the past 2 months, we have spent countless hours dedicated to cleaning, sanitizing, and disinfecting all of our facilities with an approved EPA cleaner. This work included wiping down all furniture, walls, window sills, carpet extraction, stripping and waxing of hard surface floors, and deep cleaning all of our restrooms. In response to the current pandemic, we have adjusted our cleaning procedures and added several safety features, equipment, and protocol to actively reduce the spread of the virus. We have identified the standard PPE for our district, which includes cloth face mask for every student and teacher, face shields, KN95 mask, gloves, gowns, and sneeze guards at our security entrance, secretary's desk, and our teacher's desk. PPE is a strong defense to stop the spread of the virus, so we must be the example, make others feel safe, and protect ourselves. We have placed digital temperature tablets throughout all of our approved entrances in our facilities, signage throughout the buildings to promote social distancing, and safety tips on hand washing and how to stop the spread of germs, and hand sanitizer stations in every classroom and common areas. When it comes to sanitizing and disinfecting our facilities, our custodial team in each facility will be sanitizing routinely throughout the day using an EPA-listed approved product. This will be wiping down and sanitizing touchpoint surfaces and routinely checking and sanitizing restrooms. This will be on a schedule of at least 4 times a day, specific to the building needs throughout the day based on the needs of the operation. In the classroom and other areas, the school staff will have hand sanitizer and spray bottles with a cleaner/sanitizer on hand to wipe down the desk and other areas as needed throughout the day. We will provide the chemicals to teachers along with the cleaning tools. At the end of the day, when the building is unoccupied, the custodial team will do a thorough sanitization of all areas used during the day. On Wednesdays, deep cleaning will take place along with thorough sanitizing, disinfecting of all furniture, walls, restrooms, carpets, windows, etc. All of our custodial work will be done in accordance with the CDC guidelines. Our custodial team is dedicated to ensuring a safe learning environment for the students and staff.
We are taking all of these steps in order to follow through on our promise to do everything possible to protect the health and wellness of our students, families, staff, and neighbors. Your well-being is our top priority, no matter what.
Hi, my name is Marcelina Lirius and welcome to Math Monday. Our lesson for today is solving systems of linear equations. You will need some supplies. I'll give you a few seconds to get your pen, your notebook, and if you have a calculator, that would be helpful. When you're ready, let's get started. So there are many ways of solving systems of linear equations. We can do this by graphical method, or we can do this by algebraic method using substitution or elimination. At the end of this lesson, you should be able to solve systems of linear equations by graphing. Okay. A system of equation consists of 2 or more linear equations in the variable x and y. So here are some examples of linear equations. systems of linear equations. The first two have two equations. In the third one, notice that we have three linear equations. The solution to a system of equations is an ordered pair x and y that satisfies both or all of the equations. So this means that if we have x and y as the solution, it would satisfy the equations, all the equations. It would make the equations a true statement. So a system of equation can have one solution, no solution, or an infinite number of solutions. So how does this look like graphically? So in the first figure down here, this is an example of a system that has one solution. Graphically, we now have a system. These are the two equations. If we graph this system, there is one solution, which is actually the point of intersection. The values of x and y here is common to the two linear equations, and they lie on both lines. If a system of equation has no solution, this means that the two lines are parallel. They will not intersect, and this is also shown in the equations by finding the slope of the line. So in the first equation, notice that we have y equals 3x minus 4. This is of the form y equals mx plus b. And m here is 3. B is negative 4, or is the point 0, comma negative 4. And if we look at the second line, y equals 3x plus 1, our slope here is also 3. So when the slopes of the two lines are the same, the lines are parallel and they will not intersect. In this case, there is no solution to the system of equations. Next, a system also can have an infinite number of solutions. So looking at these two equations, and if we graph these two, they actually will coincide. So which means that each point on those two lines are solutions, so there will be an infinite number of solutions. We can also see that if you have 5x plus y equals 12, then 10x plus 2y equals 24. These two are equivalent. You just multiply each term here in the equation by 2. This gives us the second line. So if you graph, it's the same line. All points on those two lines are solutions to the equation. So we have an infinite number of solutions. Graphically, the two lines coincide. Let's have our first example. Solve the system of equations by graphing. This method is very convenient if the two lines or the two linear equations are expressed in the form y equals mx plus b. Y equals mx plus b. It's easy to graph if you know the slope m and the y-intercept b. That's the slope and this is the y-intercept. So let's find these values and use these values to graph. In the first line, in the red equation here, our slope m is -1, or we can write this as -1 over 1, and the y-intercept is 5. We can write this as 0 and 5. Okay. Now, in the second line, in the green line here, y equals 2x minus 4. Our slope here is 2, m is 2 or 2 over 1, and the y-intercept is -4, which we could write as 0 and -4. Then let's plot these points. So if you always start with the y-intercept. Let's look at the red line. So the point 0.5, 0 for x, y for, 5 for y. And the slope -1 could be interpreted as you move down 1 unit, so 1 unit down and 1 to the right. 1 unit down, 1 to the right, 1 unit down, 1 to the right, 1 unit down, 1 to the right. So if we plot these points, okay, these points will now, okay, if we connect, they are on the line y equals -x plus 5. Then if we plot or sketch the line y equals 2x minus 4, let's start with the y-intercept, 0, -4, 2, 1, 2 over 1. The slope m, 2 over 1 means you move 2 units up. So 1, 2, 2 over 1, 1, 2, 1 to the right, 1, 2, 1 to the right. Okay? So if we connect all these points, okay, they will lie on this green line. And notice that these 2 points intersect at this point whose coordinates are, this is 3 and that is 2, 3, 2. So the point 3, 2 is the solution to the system of equations. And this means that these coordinates or these values for x and y will satisfy both equations or will make the equation true. I'll give you a moment to process the information. Okay, when you are graphing 2 linear equations, and if these 2 lines intersect, the point of intersection is what we call the solution to the system. And I want you also to try, what's this? The Desmos graphing calculator. You can Google it, you can use it. And here is an easy way to easily graph those 2 lines that we just worked on. Notice that y equals -x plus 5. There's a negative slope. It is this line here. And the other one, 2x minus 4. And the point of intersection is at the point 3, 2. It's easy to verify if you use your graphing calculator. Sometimes if we do it manually, we just get an estimate, not really the exact value of the intersection or the solution to the system. Let's try the second one. In the system of equations, notice that this is not of the form y equals mx plus b, so our goal is to rewrite this equation into the form y equals mx plus b. Let's try the first one. So -x plus 3y equals 6. So if we solve for y, remember when we were solving literal equations, we have to solve for y by isolating the variable y. So we add x. So this will give us 3y equals 6 plus x, or x plus 6, 3y. Then we divide both sides by 3. So this gives us now y equals 1 over 3x plus 6 over 3 is 2. Our m is 1/3 and our b is 2, or the point 0.02. That is for the first line. So if we graph this, we now have the point 0.02. 0.2 is this one. Let's interpret the slope of this line, 1/3. So move 1 up, 3 to the right. 1 up, 3 to the right. So let's connect these points, and this will have, okay, we can also move to the left, 1, 2, 3. So this will now be the line, the red line. -x plus 3y equals 6. Then let's graph the green line, okay? Let us rewrite the line or the linear equation into the form y equals mx plus b. Let me do it here. 2x plus y equals -5. So let's solve for y by subtracting 2x from both sides. So this will cancel out. This will give us y equals negative 5 minus 2x, or we can write this as y equals negative 2x minus 5. Okay, and this will give us our m here is negative 2 over 1 and b is negative 5. So let's start with our b negative 5, and the slope negative 2, 1 would mean these are opposite directions. You can move 2 down, then 1 to the right, or you can move 2 up, then 1 to the left. You can continue this, 2 up, 1 to the left, 2 up, 1 to the left. And if we connect these points, this will be the point of intersection. And the coordinates of this point will be negative 3 and 1. We call this point as the solution to the system of equations. Using the Desmos calculator, we can easily find the solution. Here, when you graph, just type these two equations on the section for the, for these equations. Then notice that these two lines intersect at negative 3 and 1. We call this as the solution. So that ends our lesson for today, and I hope to see you next week.
Kindergarten is great at Kansas City Public Schools.
I know they have really good teachers. I know this is a great school.
They teach them stuff that I thought my kids would never be able to know at the age of 5.
Since deciding to send our kiddos to a neighborhood school, we've become even more of a part of our community.
Now is the time to enroll your future kindergartner for the new school year. Visit enrollkc.org today.